Hello, welcome to this lesson of our study of integral equations. Okay, so in this lesson, what we'll do is we'll just go through how to use the Green's function to solve a given BVP. Okay, so let's start with an example. So use Green's function to solve the BVP. So this is a BVP. You have y prime plus pi squared y equals cos pi x. Okay, and given these boundary conditions, so you can see that these are not normal conditions. At first, we were given y of 0 equals, let's say, y of 1, and it's equals a certain constant, let's say 0. Then but here it has been given in two ways, that y of 0 is the same as y of 1, and y prime of 0 is also the same as y prime of 1. So you use these two conditions to check. Okay, now indeed they've asked us to use Green's function. We should at the same time go ahead and solve the homogeneous part. Okay, but before that, using the Green's function, okay, so if you use the Green's function, then the solution to this question, okay, so let me write this in the general form. Okay, if you have in a general form, if you have a second order BVP, which is P y prime plus, let's say R y prime, okay, because we've been using Q for the y, okay, plus QY plus some file of X, okay, some file of X equals 0, and a file of X is a function of only X. Okay, if file of X is a function of only X, then you are solving the BVP using Green's function. Okay, we'll consider a case where the file of X is actually a function of both X and Y, and that is a different topic. Okay, so here we consider this as a function of what? Only X. Then the solution to the BVP given as this, okay, this one, the solution to that is given as y of x is equal to integral from your let's say alpha beta, where alpha and beta are the boundaries, okay, then g of xt, okay, then file of t dt. Okay, so it means that for every second order BVP given, I should know my file of x to be able to find file of t. Okay, I hope you get this. And then we just go ahead and find our Green's function, come and put it here, and we'll be done. Just do a normal integration, that is all. Okay, so let's look at this. So this question is y prime plus pi squared y equals cos pi x. Okay, so if I try to send this side to this cos pi x to this side for it to look like this, okay, then it will get something like y prime plus pi squared, okay, y minus cos pi x, and this is equal to 0. So this means that if I compare this to what I've written here, okay, my p is actually equal to 1. My q is equal to pi squared, and my r is obviously 0, which is the coefficient of y prime. And then my file of x here is equal to minus cos pi x, okay, which means that file of t would then be equal to minus cos pi t. And we know the boundary. The boundary is from 0 to 1. Okay, that's the boundary given, because all the conditions were defined for 0 and 1. Okay, so this means that if I use this method, it means for this particular question, okay, let me use the red pen. For this particular question, our solution should look like this: y of x equals integral from 0 to 1. Okay, so you are writing the solution, and go and look for the unknowns and come and put them here. Okay, 0 to 1, okay, then g of xt times our file of x, and file of x what is negative cos pi t. Okay, the t. I hope I wrote the t here. Yes. This implies that my y of x here will be equal to minus integral from 0 to 1 g of xt cos pi t. Okay, so all that you will just go and look for is our g of xt. That is why, then come and put it here and we'll solve our BVP. Okay, so let's go ahead and look for the g of xt. We said that if you have your y prime prime plus pi squared y equals cos pi x, okay, to find the Green's function, what you do is you write out the homogeneous part of this BVP, and that is y prime prime plus pi squared y equals 0. Then you solve this. Okay, you have a second order ODE, okay, with constant coefficient, so we can say that we let our solution y of x be equal to e to the rx. Okay, that means y prime will give me r e to the rx, y prime prime will give me r squared e to the rx. Okay, so I put the corresponding terms here. Y prime prime is what? R squared. So I just put it back in this equation. Okay, so r squared e to the rx plus pi squared e to the rx, because y is given as this and y prime prime is given as that. Okay, and this is equal to 0. That's the homogeneous part. So if I factor e to the rx out, e to the rx, then I have r squared plus pi squared, okay, is equal to 0. So I have the product of two functions or two terms. I'm saying it's equal to 0. It's either this is equal to 0 or this is equal to 0, or both. But we know that e to the rx is our solution and it's never equal to 0. Okay, so this implies that r squared plus 1 is actually equal to 0. This, I should have actually started with this. Okay, some books will just plus pi squared rather. Okay, r squared plus pi squared is equal to 0. Some books will just start with r squared. The solution is r squared plus pi squared equals, but I just wanted to show you how to go about it in case you didn't get something like this. Okay, so therefore your r, you have r squared plus pi squared equals 0. And this means my r squared is equal to minus pi squared. And it means that my r is equal to plus or minus pi I. Which means we said that if you have complex numbers, your y of x is simply equal to a cos of the magnitude of whatever that is here. And that is pi. So pi x plus b sine of the magnitude, which is pi what x. You are done. Okay, that is your general solution for the homogeneous part. Okay, so we check if this is indeed there exists a Green's function. So if there exists a Green's function, then y of x equals 0 should be the trivial solution to this. Okay, so in the how do you call it, condition, we say that y of 0 is equal to y of 1. So y of 0 means that I'm just putting 0 in place of x. So if I put 0 in place of x in this, if I put it at the cos place, I'll get cos 0, which is 1. So I have a, and in the sine, I'll get sine 0, which is 0. So I have a equals, okay, y of 1. When I put 1 here in place of the cos, I'll get cos of pi, which will be minus 1. Okay, and times a will give minus a. When I put 1 in place of the sine, I'll get sine pi, which is 0. Okay, so I'll have 2a equals 0. And this implies that my a is equal to what? 0. So this means that my function has reduced to y of x equals b sine pi x. Okay. Alright, so let's look for b. We said that y prime of 0 is the same as y prime of 1. Now this is y. This is how y has reduced, because a is 0. Okay. This means that y prime of x would then be equal to b pi of what? B pi cos pi x. Okay. So y prime of 0 means that I just have to put 0 in place of x in this. Okay. So I have, when I put 0 in place of x here in b pi cos pi x, I'll get just cos 0 times b pi. Cos 0 is 1, so I have b pi or pi b. And this is equal to, when I put 1 there, I'll have cos of pi. Cos of pi is negative 1, so I have minus b pi. Okay. Right. This I'll have 2b pi equals 0. If I divide through by 2 pi, I have b equals 0. So this has also shown that y of x, if you put b here, okay, we'll have y of x equals 0. The trivial solution indeed exists. So it means that there exists a Green's function, okay, and giving y having general solution as a cos pi x, okay, plus b sine pi x. Okay, it means that my Green's function, the first point is that you are saying that the Green's function should look like this. It should take this form. So g of xt should be equal to, the first point, a1 is a piecewise function. Okay, if you remember, is a1, okay, a1 cos pi x plus b1, okay, if one can call it any name. So b1 sine pi x, then within the limits or within the range of 0 less than or equal to x less than t. Now you come to this one and you get a2 cos pi x plus b2 sine pi x. Okay, I have t less than x less than or equal to 1. So this is my Green's function. So my task here is to go and look for a1 b1 a2 b2. Okay, and the second point is that we always say that the Green's function should satisfy the boundary condition. Okay, you should satisfy the boundary condition, and you are saying the boundary condition is that g of, or y of, let me write it, y of 0 should be equal to y of 1. Now you go back to your Green's function, you realize that 0 is in g1. Okay, it's in the first part, and 1 is also located here, so it belongs to this. Okay, so it means that if I'm to use what we have, it means g1, okay, of 0 t should be equal to g2, okay, of 1 t. Okay, and this means if I put 0 in place of x in g1, okay, let's go back. If I put 0 here, I'll get a1 times cos 0, which will be just 1, so I'll have a1. Then plus, when I put 0 in place of x in the sign, I'll have sine 0, which is 0, so I have just a1, and it should be equal to putting 1 in place of x in the 2, so a2 times cos pi. Cos pi is what? Minus 1, so I have minus a2. Okay, and then with the b2, okay, b2 is simply, how do I call it? b2 is simply, when you put 1 here, I have sine pi. Okay, sine pi is also 0, so you make that place 0. So I have a1 equals 8 minus a2. So I'll have this a1 equals minus a2. Okay, let's call this our first equation. Now the second condition, two conditions were given, that y prime of 0 is equal to y prime of 1. And again, it means that the 0 belongs to the g1 and the 1 also belongs to the g2. So it means you should find g1 prime of 0 comma t should be equal to g2 prime of 1 comma t. So what you find is g1 prime, okay, g1 prime is equal to, just differentiating this one, the whole of this, with respect to x. So we assume that the Lagrange function is a function of x, and that you get what? Minus a1 sine, or a1 pi, sorry. Know how to differentiate trigonometry. You differentiate the cos, you get minus sine of pi x. Then you differentiate here the pi x with respect to s, you get pi. Then you multiply it to it, so you get minus a1 pi, okay, sine pi x. Then here you get plus b1 pi cos pi x for the derivative for the g1, okay. So here you get minus a1, where is it, minus a1 pi sine pi s plus b1 pi cos pi x, okay. Now g2 prime, the same thing, just that the variables will change. So I have minus a2 pi sine pi x, okay, plus b2 pi cos pi x. I hope you can do this. I hope they are cool, right? So what you do is just wherever you see x in the g1 prime, you put 0 there, okay. So if I put 0 here, I'll get sine of 0, and that will give me 0. But cos of 0 will actually give me 1. So it means I'll get b1 pi, okay, from the g1 prime of 0t, I'll have b1 pi, which is equal to, and it comes to the g2 prime of 1t. When I put 1 in place of x, the first term here, I'll have sine pi. Sine pi is 0, and cos pi is negative 1, okay. You put 1 in place of x, so you get cos pi, which is negative. So you get minus b2 pi. So pi will cancel pi. So I have another equation saying that b1 equals minus b2. You call this equation 2. Okay. So let's go ahead with the third point. The third point is saying that g1 of tt should be equal to g2 of tt. And you know your g1 and g2, okay. So you come to these g1s and g2s, okay. So you come to these ones, wherever I see x, you put t there, and for the g1, the first part, this part, and wherever you see x in this one, you put you put t for the second one, and you create them, okay. They should be equal. So what you get is, you get something like this: a1 cos pi t, okay, plus b1 sine, let me write it over for you, sine pi t should be equal to a2 cos pi t plus b2 sine pi t, okay. But we know a1 and I think b1, okay. I hope you remember, you know a1 and b1 from this equation. A1 is equal to minus a2 from equation 1 here, and b1 is minus b2, okay. So I'll go ahead and put them there, okay. A1 is minus a2, so I have minus a2 cos pi t. Now I have another cos pi t here, so I just bring it here and I get minus a2 again cos pi t, okay. Then b1 is also minus b2, so I have minus b2 sine pi t. Then I bring the whole of this to the other side as well, so minus b2 sine of pi t. The whole of this should be equal to 0 because I've brought all these ones to the left side, okay. So I have minus 2a2 cos pi hot cos pi t minus 2b2 rather sine pi t should be equal to 0. So I divide through by 2, okay, and I'll get something like this. Or I divide through by negative 2, and I'll have something like a2 negative 2. So I have a2 cos pi t plus b2 sine of pi t. Let me write it all. Sine of pi t equals 0. So from this, it simply means that if I make a2 the subject, a2 is equal to minus b2 sine pi t over cos pi t. I hope you get this. So you call this equation 3 as well, okay? Now I go to the last point, the fourth point, which states that, so with the fourth point, it states that with the second order del g, let me write it well. With the fourth point, I have del g of xt, so del g of xt del x at the point x equals t should be equal to minus 1 over p of t. Now if you remember, when I started, I wrote p is equal to what? 1. So it means p of t is still a constant function. I have 1. Okay. So this means that now del g, differentiating this, is simply del g2 of xt del x, okay, at x equals t, then minus del g1 of xt del x at x equals t should be equal to negative 1 over 1, which is negative 1, okay. Now del g2 of xt, what did we get for that? Del g2 of xt is simply differentiating g2, that is g2 prime, and this is what we had for g2 prime. We had this, okay, minus a2 pi sine pi s plus b2 pi cos pi s, okay. So you go ahead and write it there like that. So I have minus a2 pi, is sine pi x? Yes, sine pi x, okay, pi x plus b2 pi cos pi s. All of these evaluated at x equals t, then minus, okay, so I'm writing the other one here under this. So I have minus a1 pi sine pi x plus b1 pi cos pi x, okay. All of these evaluated at x equals t, and it should be equal to negative 1. Okay, so let's put s equals t in place of all of them. Okay, now we will get something like minus a2. Okay, we'll get minus a2 pi. Okay, a2 pi sine pi t. Okay, let me see, plus b2 pi plus b2, let me see, okay, minus, so there should be a bracket here so that the minus will affect everything. Okay, so there is a minus here which will affect everything. b2 pi cos pi t, okay, then minus into a1 pi, let me write it at the down here. Okay, let me write it minus big, minus a1 pi sine pi t okay, there's a minus a1 here, so minus that plus b1 pi cos pi t. Okay, this you got negative 1. Now let's try to simplify. Okay, so I have minus a2 pi sine pi t. Okay, sine pi t plus b2 pi cos of pi t, right? Then plus, because the minus is affecting everything here, so plus a1 pi sine pi t, then minus b1 pi cos pi t. Pi t should be equal to negative 1. Okay, so if you remember, we know a1 and we know b1. We say a1 is equal to minus what, a2. Okay, so if I put it there and b1, okay, I'll have minus a2 pi sine pi t. Okay, this is a1 pi sine pi t. Okay, but a1 is what, minus a2, so I write it here, minus a2 from our first equation, minus a2 pi sine pi t. Then I have b2 here, right? But b1 is what, minus b2. Okay, let me see. Yes, so I have plus b2 pi cos pi t. Then it was supposed to be minus this. Okay, but b1 is minus b2, so when I put it here, we can minus, so I'll get what, plus b2 pi cos pi t, and this you got negative 1. Okay, so if simplifying this, you get minus 2a2 pi sine pi t, sine pi t, then plus 2b2 pi cos pi t equals negative 1. Okay, so if you divide through by 2 pi, this is a very long question, but I decided to bring this because all our questions have been simple like that. So a2 sine pi t, okay, where is it? A2 sine pi t, so minus a2, then plus b2 cos pi t should be equal to negative 1 over 2 pi. So if I divide through by negative 1, okay, I'll have a2 sine pi t, okay, minus b2 cos pi t equals 1 over 2 pi. Okay, now if you remember from equation 3, so the equation we named it 3 from 3, equation 3, let me go and show you. This is our third equation. A2 is this. Okay, so wherever you see A2, you put this there in the new equation you've gotten. From 3, A2 is actually equal to minus b2 sine of pi t over cos of pi t, right? So this simply means that if I put a2 here, okay, I'll get something like minus b2, okay, then I multiply the whole of this to sine pi t. Then we have sine pi t already there, so I have sine squared pi t over cos pi t. okay, cos pi t, minus b2 cos pi t, and it's equal to 1 over 2 pi. So if I factor my minus b2 out, okay, minus b2 out, I have sine squared pi t over cos pi t plus cos pi t, and this is equal to 1 over 2 pi. Now I realize that if you simplify the bracket here, okay, the LCM is cos pi t, so you can go through that fraction yourself. You get a final answer for the fraction to be sine squared pi t plus cos squared pi t over cos pi t, and this is equal to 1 over 2 pi. And you know that the top one is 1, okay, in the fraction. So I have minus b2 over cos pi t should be equal to 1 over 2 pi. So if I multiply through by negative 1 over cos pi t, I'll get b2 equals minus cos pi t over 2 pi. Okay, so what you can do here is you can actually simply multiply through by cos pi t, then at the end you divide through by negative 1. Okay, so I didn't do anything big. Okay, so from this we know that b1 is equal to minus b2, so this implies that b1 is equal to negative of what we've gotten, okay, negative of this, and that is simply cos pi t over 2 pi. Okay, now we know that from equation 2 or from 3, what we just stated before finding b2, we said that a2 is equal to minus b2 sine pi t, okay, sine pi t over cos pi t, which is equal to, now b2 gave us what, minus cos pi t over 2 pi, okay, minus cos pi t over 2 pi. So if I put it here, I have negative, so I have cos pi t, okay, over 2 pi times sine pi t over cos pi t, and this can take this out, and we'll have a2 to be equal to sine pi t over 2 pi. And then definitely we said a1 is equal to minus a2, and this shows that a1 is also equal to minus sine pi t over 2 pi. I hope you got this. So this is very simple, and this is our Green's function now. So our task is to solve it. Okay, so the Green's function g of xt, we said is equal to a1. Okay, so it was a1 cos x or pi x, okay, plus b1 sine pi x, and the limit is 0 less than or equal to x less than t, and then this one is a2 cos pi x plus b2 sine pi x, then t less than x less than or equal to 1. So this is actually what we wrote. So we know our a1, we know our a2, we know our b1 and b2. So g of xt is equal to, very simple like that, minus 1 over 2 pi, okay, sine pi t, that is our a1, cos pi s, then our b1 is plus 1 over 2 pi cos pi t sine pi s, okay. So with the limits, okay, so write the limit here, this limit there. It wouldn't go there, so just write it there. So I have this 2 as 1 over 2 pi sine pi t cos pi x, okay, then minus 1 over 2 pi cos pi t. Is it cos pi t? Yes, okay, sine pi x. And you write the limits or the range here as well, okay? So this is your Green's function. Wow, this is very tedious. So the next task is to find the solution, okay? So the actual question was we should solve for this, and we said that the solution is y of x in the starting point, I said, is equal to minus integral from 0 to 1 g of xt, okay, then cos pi t dt, okay. And we know that u of xt is given as this one, okay, it's a piecewise function, okay. So we are integrating from 0, let me use a red pen for you, from this range 0 to what, 1, but t or x is broken down into different limits. So from 0 to t in terms of x. Now we are integrating with respect to t, so we will use from 0 to x rather. So we will use this. We change all the x's to t in this one, okay, and that is as well this as well, okay, and here to change all the x's to t, okay, and we use our basic limits, okay. So what you can also do is that if you don't want to confuse yourself with changing the limit and the rest, you pick this, you integrate using this limit, okay. The limit t will be within this x and less than or equal to 1. So you pick the first one, you take the second range for it, and you pick the second one, you take the first range for it, if you don't want to be changing the t and the x, okay. All right, so let's go ahead and apply that, okay. So this is it. Now you are asked to perform this whole integral. So we have y of x is equal to the negative of the integral 0 to 1 of, so the g of x st is broken down into 2, like I said. So it's first we consider from 0 to s, then we consider from x to 1, okay. So the 0 to x is the range for the first g1. So I said in the integral, when you are solving, use this range for this one, okay. So it means that you are using this range here for this. So the first range for the second, that is the range you use for the g2, should be the first range, okay. So g2 is given as what, where is my g2 minus, so it's negative of everything. Let me use a green pen here. So it's negative of everything, okay. So minus 1 over, let me do this, 1 over 2 pi, okay, sine pi, this one I know is tedious, but let's do this, okay, sine pi t cos pi x, okay, then plus 1 over 2 pi, okay, cos pi t sine pi x, okay, all of this times cos pi x, or is it cos pi t? Sorry, phi of t is cos pi t, okay, then dt, okay, there should be a dt there, you can add it, then plus the integral from x to 1, and this range is for the second one, okay. It's a range for the g2, but when you are coming to integrate, use this range for the g1, okay. So g1 was given as what, g1 was given as 1 over 2 pi sine pi t, okay, is this sine pi t? 1 over 2 pi. Wow. Where is my x to 0 to x? Let me see. 0 to x, you use g2. Okay, that is correct. Let me go and check. Okay, because it's like, so 0 to x, you use g2. Wow. Okay, and then t to 1, x to 1, you use g1. Okay, so it means that here these limits are wrong. The limits for the first one I wrote, this is supposed to be, because this first one, this here is what, g1. Okay, so the limit is supposed to be x to 1. Okay, so you use the second limit for g1 in your question. Okay, and you use the first limit for, or the first range for g2. Okay, so this one should be 0 to x rather. So 0 to x. Okay, I hope this is cool. So sine pi t cos pi x. Okay, then minus 1 over 2 pi cos pi t. Okay, sine pi x. All of this times cos pi t dt. Okay, dt, everything is dt. So let me use the green pen to cover it. So it's like this, the negative of everything. Okay, there's a negative here, take notes. Okay, so let's pick them one by one and do the integration, and we'll just close. Okay, so we pick the whole of this, integrate it, we come and add it to the integral of this. Okay, so with the first one, that is integral from x to 1. Okay, negative 1 over 2 pi sine pi t cos pi x plus 1 over 2 pi cos pi t sine pi x, and all of this multiplied by cos pi t dt. Okay, so if I expand this, I'll get something like this: integral x to 1 over 2 pi, or negative 1 over that. Okay, or let me say 1 over that. I'm multiplying this. Okay, the cos pi t to this, then I subtract from this. Okay, because there's a negative here, so I don't want to be getting negatives in front. So I have this, then cos pi squared t, or cos squared pi t, sorry, it's supposed to be cos squared pi t, cos squared pi t, then sine pi x dt minus integral from x to 1. Okay, then I'll have what, 1 over 2 pi sine pi t cos pi t cos pi x dt. Okay, the last one is cos pi x dt. So this is equal to, factor some terms out, sine pi x, okay, over 2 pi integral from x to 1 cos squared pi t dt minus cos pi x over 2 pi integral from x to 1 sine pi t cos pi t. Okay, so what we are coming to do is just do these simple integrations. Okay, but integral, or let's say cos squared a is equal to 1 over 2 plus cos 2a over 2 is how do you call it, an identity. Okay, this implies that cos squared, okay, cos squared pi t, where pi t is a, is equal to half plus cos 2 times a and 2 times pi t. So you have 2 pi t over 2. Okay, and also from sine a, okay, another identity, sine a cos b is equal to, from this identity it says 1 over 2 into sine of a plus b plus sine of a minus b. Okay, so where here this implies that sine of pi t cos of pi t should then be equal to half, okay, both a and b are pi t, so I'll have half sine of 2 pi t, because pi t minus pi t will give me 0, so sine 0 is also 0, so I have this. So this means that my whole integration will just change to a simple one. Okay, that's the first term that we are doing. Okay, this implies we have sine of pi x over 2 pi integral of cos squared pi t, and that gave us what? So this is x to 1. Cos squared pi t gave us half plus cos 2 pi t over 2 all the t, then minus cos pi x over 2 pi, the integral 0 to, is x to 1. Then this gave us half sine of 2 pi t dt. Okay, now let's start performing the integrals. When you perform the first integral, you get sine pi x over 2 pi, and if you integrate this, you get half t. Integrate cos 2 pi t. Okay, it's cos 2 pi t over half. So with the over 2, with the over 2, you don't consider that. Just consider integrating cos 2 pi t, and that will give you just the, when you integrate cos, you get positive sign. So integrate cos 2 pi t, you get plus let me write it straight, sine 2 pi t. Okay, then divide through by the differential of 2 pi t with respect to t, and you get 2 pi. So you divide through by that, you get what? 4 pi. Okay, 4 pi like this. Then the limit is x to 1. Okay, then minus, then cos pi x, okay, over 2 pi into the integral of this will give you minus 1 over 4 pi. Okay, you know how to cos, integrate sine, you get minus cos. Okay, so you apply the same thing, cos 2 pi t, then from x to 1. Okay, so this is tedious, but let's go through it. Let's kindly go through it. Okay, so if when I put in the limits, okay, for the first part, I'll get what? When I put 1, I'll get half plus sine 2 pi over 4 pi. Okay, where is it? So sine 2 pi is actually 0. So get half plus sine 2 pi over 4 pi. And sine 2 pi is 0, so we get half plus 0 minus, when I put x in, and we'll get half x plus sine 2 pi x over 4 pi. Okay, so I'm coming to actually write it straight away. That is why. So I'll have, if I put the limit in, I have sine, where is it? Sine pi x, okay, over 2 pi into half minus 1 over 2x minus sine 2 pi x over 4 pi. That's when I put the limit in. Okay, I hope I explain it. Now minus cos pi x over 2 pi. Okay. Now with this, if I put the limit in, let's go ahead and check. If I put 1 in, I'll get cos pi 1. Sorry, cos minus 1 over 4 pi times cos 2 pi. And cos 2 pi is also 1. So you get minus 1 over 4. Okay, then minus 1 over 4, then cos 2 pi x. And that will give you minus 1 over 4 pi plus 1 over 4 pi cos 2 pi x. Okay, I hope you get this. So let me put it here. You get minus 1 over 4 pi plus, plus 1 over 4 pi cos 2 pi x. Okay, so you go ahead and do your simplifications. You multiply through by whatever that you have. So I have sine of pi x over 4 pi minus x sine of pi x over 4 pi. Okay, I think this is all you have. The rest will give you 0, but let's go through it and know why is 0. Okay, then minus sine of pi x sine of 2 pi x all over 8 pi squared. Okay, then minus, okay, so this is for only this part, so minus the whole of this. Okay, minus this. So when I multiply minus of this times that, I'll get plus. Okay, get plus cos pi x over 8 pi squared. Okay, 8 pi squared, then minus cos pi x cos 2 pi x over 8 pi squared. All of these are just part of the first part of the integral we just started with. Okay, so you can see that I just want to remind you that all of this is all we are doing is just this part. Okay, just the advantage here is that all these integrals will repeat here, just that the limits will change. Okay, so when you come to the second one, we just put in our results and we just change the limits. That is all. Okay, I hope you get this. So this is what we have here, and I'm saying that this one, this from here up to this point will give you 0, but let's go through it. Okay, I want to prove to you and probably use the same thing for the next term. Okay, so this means I have something like this. You have sine pi x over 4 pi minus x sine pi x over 4 pi. Okay, and minus into brackets sine pi x sine 2 pi x plus, okay, let me put this over 8 pi squared plus cos pi x cos 2 pi x over 8 pi squared. Okay, all of these in bracket, then plus cos pi x over 8 pi squared. Okay, so if I solve the one in the bracket, I'll have sine of pi x. I'm just proving why is 0. It's 0, but I'm just showing it to you. Okay, minus x sine of pi x over 4 pi, then minus the bracket here has the same LCM. So I have sine pi x is minus that, okay? Sine 2 pi x plus cos pi x cos 2 pi x, okay? All over 8 pi squared, okay? Then plus cos pi over 8 pi squared. Now I realize that this is cos of something, okay? Let me write it well for you. You know, cos of 2 pi x plus pi x, sorry, minus pi x actually, or should it be plus? I think it's minus, right? Minus pi x minus pi x, okay? Only this will give me what? This is equal to, if I'm to expand using the double angle formula, okay? If I'm to expand using the double angle formula, then this will give me cos of 2 pi x, okay? Cos of pi x, then plus sine of 2 pi x sine of pi x. And realize that this is what you have at the numerator here, okay? I'm sorry, at the numerator here, that is what you have. Just that the cos of 2 pi and the rest are here, and the sine is also here. It's the same thing. So it means that the whole big thing here over 8 pi squared would then tend to become cos of this, okay? Cos of 2 pi minus pi, and that will give me what? Cos of pi over 8 pi squared, okay? So that fraction simplifies to that, and it will imply that we will have something like sine of pi x over 4 pi minus x sine of pi x over 4 pi, then minus this is what the fraction has given us. So minus cos pi x over 8 pi squared, then plus cos pi x over 8 pi squared, and this will take this away. So I have only this thing. That's why I said this is just 0. So just that I just wanted to prove to you. So it means that the first part of our integration, the first part in the Lagrange function gave us, so let me write first part, gave us where is it? Sine of pi x over 4 pi minus x sine of pi x over 4 pi. So let's keep this somewhere, okay? Now you go to the next part, which is also very tedious, but then with that one, we, like I said, we know some terms already, okay? So this is the next part. This is the part that gave us, this part is the part that gave us what we had, okay? So we're going to this part, and luckily enough, we know some parts already, so it will just be easier for us to do, okay? So let me write that whole thing. Second part is this. The second part we have something like this. We have integral from 0 to x, okay? 0 to x, 1 over 2 pi sine pi t cos pi x, okay? So here I'll be jumping steps because I hope you'll be able to pass through the same process like I did for the other one. Then cos pi t sine pi x, okay? All of these times cos pi t dt, okay? Now if you multiply through cos pi t and simplify, this is what you get, okay? You get, this will give you cos pi s over 2 pi. Is it 2 pi? Yes, 2 pi. The integral from 0 to x sine pi t cos pi t dt. And we know this because we did it and we said it simplifies to half sine 2 pi t. And that one too, its integral gave us something. So I'll write into this final answer it gave us straight away. Okay, so then I think we have minus. Okay, integral from 0 to there's minus. Then let me write it here for you. Okay, so I have minus. Let me write it here down here for you to see. Sine pi x over 2 pi integral from 0 to x, and I have cos squared pi t dt. Okay, and this one too, its integral we know. So you see that the moment you're able to do the first term, the second term becomes easier. Okay, so this means we have cos pi x over 2 pi. Then the integral of this, it gave us what? Let's go back and check. That integral, where is it? This part is this part that was giving us sine pi t cos pi t, and it gave us this, and its integral gave us this one. Okay, so I'm going to copy this, just 1 over 4 pi cos 2 pi t. Then the limits will just change. Okay, so I have where is it? Minus. It's minus actually. Okay, so I have minus 1 over 4 pi. Okay, cos 2 pi t from 0 to x. Okay, minus sine pi x over 2 pi. Then this part too, the answer gave us, if you remember, it gave us half t plus sine 2 pi t over 4 pi, right? And from 0 to x. Okay, so if I put in the limits, now I'm going to compute this straight away. Please, cos of 0 is 1. I'm just mentioning them. Cos of 0 is 1 and sine of 0 is also 0. So every other simplification, just cos pi x will be cos pi x and the rest. Okay, so if I simplify everything and put in everything, this is what this thing will also give me. It will also give me I'm just writing everything straight. Okay, or I should just take my time. Okay, when I put in the limits, let me take my time and go through it. When I put in the limits, I'm getting cos pi x over 2 pi, then minus 1 over 4 pi cos 2 pi x. Okay, minus that, and that will give me plus 1 over 4 pi. Okay, and minus sine of pi x over 2 pi into half x plus sine 2 pi x over 4 pi. Okay, so you expand this and simplify, you get minus cos pi x, okay, cos 2 pi x over 8 pi squared. Something is also happening here. Then plus cos pi x over 8 pi squared. Okay, then minus x sine pi x over 4 pi, then plus, is it plus? There's a minus here. Okay, there's a minus here, it's affecting everything here, so there's another minus as well. Okay, so here should be minus. So minus sine pi x sine 2 pi x all over 8 pi squared. Okay, and I realized that we had this term. Okay, let me use the green pen. In the first part, we had this term, also this term, and this term, and they all added and summed up to 0. We know this already. I went through with you that the combination of these two, this one and this one, will give you a negative cos pi over 8 pi squared. Okay, using the double angle formula, I just did that. And when you add it up to this, you get 0. So it means that the second part is also giving us this. So second part is giving us the final answer for the second part is minus x sine pi x over 4 pi. Yes, because it will be left with only this part. Okay, so it means that my solution y of x is equal to negative of everything that we were doing. So the negative of the first part was what? The first part was 1 over 4 pi minus x sine pi x over 4 pi. Then minus, because the second part is also this. So we are just adding them. X sine pi x over 4 pi. Okay. And this is equal to, if I multiply through by negative, I'll get negative 1 over 4 pi, okay, plus x sine of pi x over 4 pi plus x sine of pi x over 4 pi. Now you realize that this and this one and this one are the same, so it's two of them. So 2 that, okay. So we have minus 1 over 4 pi plus 2 x sine of pi x over 4 pi, and then you can either divide this by this and get 2 pi and leave it like this, or you can go ahead and say that this is y of x. So y of x y of x is actually equal to, now I factor 1 over 4 pi out, okay, and here I'll be left with negative 1 here. I'll be left with plus 2x, okay. I hope you get this. Plus 2x, let me see. I think there is something I didn't write. Let me see. The first part here is wrong, right? Here is supposed to be minus pi or something like that. So minus s sine of pi x, okay, over 4 pi. This is what we're supposed to get, this y of x. So I think this part is also supposed to be minus sine of, okay, minus sine of pi x, okay. This is what we're supposed to get. So this means that yes, this is right, and we'll get sine of pi x here, okay, sine of pi x here. So if I multiply through this, I'll get this back, okay. So y of x is now simply equal to 1 over 4 pi, okay, times 2x minus 1 times sine of pi x. Okay, so I just wanted to exclude the trig part. That is why I did the factorization. Okay, I hope you understood the process. I know it's very, very long. It's really long. Yes, no one will tell you that this is not long. It's very, very long, and that just pardon me on that, but I have 2 trials here that I want you to go through. The trial I have for you is, the first one is use Green's function to solve these. Okay, so y prime plus y is equal to s squared subjected to y of 0 is equal to y of pi on 2, and this is equal to 0. So using Green's function, the expected answer is y of x is equal to 2 cos x plus 2 minus pi squared over 4 sine of x plus s squared minus 2. So this is the expected answer. Okay. Now the second one is leave your answer in terms of hyperbolic. Okay. This first one. The second one. Second one is y prime prime minus y equals minus 2e to the x. Okay. Subjected to y of 0 is equal to y prime of 0. And again, y of L plus y prime of L should be equal to 0. These are the conditions given. And then the answer to the second one is leaving your answer in hyperbolic functions. Okay. Y of x is equal to sine x plus e to the x into L, the L in the boundary L minus x. Okay. Now, I know when you solve for the homogeneous part of this, okay, you get r to be equal to plus or minus 1. Okay. R will be equal to plus or minus 1. Okay. You got this. So you get R to be equal to plus or minus 1. But the moment you get same but opposite signs, you can use sine and cos. Okay. Then you write your general solution or general answer as A cos x. Okay, H cos x plus B sine x. This is because I wanted to actually prove this, why this is true, but I'm sorry there's no time, and I would urge you to go ahead and do that, because if you realize cos, let me take my time to explain this. Okay, this will actually state that y of x from the question given in question 2, y of x should have been a e to the minus x plus b e to the x. Anyhow you want to write it, you can write a e to the x plus that. But this is the same as this, because cos s is giving us 1 over 2 e to the x plus 1 over 2 e to the negative x. Okay. And sine s is equal to 1 over 2 e to the x minus 1 over 2 e to the negative x. When you add these two, okay, when you add the two, it means cos x plus sine x, okay, is equal to e to the x. Okay, I hope you get this. And now if you subtract the two, you get cos x minus sine x is equal to e to the negative x. Now put e to the x is this, and e to the negative x is this. Put it back in this. Okay, you get a situation whereby you have so you have y of x equals, let's say, a e to the x plus b e to the negative x, and you know all these, e to the x is that, e to the negative x is that. Okay, so you have y of x being equal to a e to the x is what? So a cos x plus a sine x, then plus b cos x minus b sine x. Okay, so you don't know b, you don't know a, so if you factor cos, you get a plus b, then cos x, then plus a minus b sine s. A plus b is still a constant, so I have d cos x plus another constant, let's say c sine x, and I can call these constants anyhow, so I can still say that yes, y of x is still the same as a cos s plus b sine s, and it doesn't change anything. Okay, or you can say d or c. Okay, I hope you get it. So when you have the same but opposite sign of roots, then you can actually use cos and sine. Thank you, and I think we've done a lot you've really done a lot. Okay, so don't forget to subscribe to my channel for more videos. See you next time.